stoichiometry of gaseous reactions or gaseous reactions. Now, when you do these kind of problems, you have to remember that this is a more of a genuine problem-solving question, because it's asking you to think about the question and develop a strategy. Now, before we begin, I'm going to tell you, make it a little bit simpler for you, and I need to tell you that whenever you do these kind of questions, you have to keep in mind, that you're only referring to the gas, right? You're only looking at the gas part of the equation, okay? So pressure, temperature, volume apply to substance in gas phase. That's number one. And number two is these kind of problems always go this way. You either start with PV equals nRT and solve for one of these unknowns, let's say a variable, like you're solving for n, and then do stoichiometry, or you would have to do stoichiometry and then do PV equals nRT. So you have to decide. And it's very, very, you can tell right away what you should do first. So be aware of these kind of problems because, again, they're multi-step. So let's look at this question. This question is giving you an equation. So you'll know that this is a stoichiometric problem when you have an equation. So this question is giving you an equation. It says potassium chlorate, when it decomposes, it produces potassium chloride and oxygen. And again, let's pay attention to these right here. The two, because we're going to need them for stoichiometry, to 2 to 3. We need these ratios. So let's read the question. It says, suppose you heat 1.51 grams of potassium chlorate. So we're given the mass of potassium chlorate in a test tube. How many liters of oxygen, O2, can you produce at 298 Kelvin? So it's already converted for us, and 1.02 ATM. Very well. So you are probably likely to start by saying, yes, I can do the following. I can just solve for the moles and plug into PV equals nRT and I'm done. But you should be careful because you're committing a mistake here. What is the mistake? And hear me very, very carefully, okay? Take me seriously for a moment, okay? Potassium chlorate is a solid. You cannot apply PV equals nRT to the solid. So we're giving here the mass. We're given 1.51 grams of potassium chlorate. So we can't convert this to the moles of potassium chlorate and plug in. What you would have to do is you would have to go with this route right here. You have to take stoichiometry. You have to have stoichiometry take you to the moles, So from the grams of potassium chlorate to the moles of O2, So that's what we're going to do first, is we're going to go from the grams of potassium chlorate to the moles of O2. Okay. So if you recall from stoichiometry, we would have to divide by the molar mass of potassium chlorate first. And that would be, if you calculated, 122.55. Once again, you get this from the periodic table. And you have 1 mole of potassium chlorate. So you divide by the molar mass. Let me remember this. Let me show you this. Grams of A divided by molar mass times ratio times molar mass of, which gives you grams of B. And here in the middle, you have moles of A. Here you have moles of B. So where are we? We are given the grams of A, and we need to go to the moles of B. So we're dividing by the molar mass of A, and then multiplying by the ratio. Very well. What's the ratio of oxygen to potassium chlorate? It's 3 to 2. 3 moles of O2 to 2 moles of potassium chlorate. So the moles of potassium chlorate go down here, so they can cancel out. And the moles of O2 go on the top. And now we can cancel, we can cross out stuff. So it goes 151 times 3 divided by 122.55. So if we calculate this, and that gives us 0.0 369. Now we have the moles of O2, which is N. Now we can plug into this equation, the PV equals nRT. You could not plug in this right here because this is not a gas, this is a solid. Very well, so now we need to calculate, it says how many liters of oxygen. So we need the volume. So you divide each side by P, and that would give you V equals nRT over P. So let's plug in. And we just calculated right here. Remember, R is 0.0821. That's the constant. Mole K. And then T is given to you right here. It is 398. Or sorry, 298. Divided by the pressure, which is 1.02 atm. So if we solve for V, it would be multiplying across, then dividing by what's on the bottom. And that would be 0.885 liters of oxygen. So think about this question. You can replay the video multiple times and see why I started with the grams and then did stoichiometry and did this PV equals nRT equation. There are instances like in your homework where you have to do this first and then go to the grams. Generally, if you're given the grams, means you have to do stoichiometry first and then do PV equals nRT. And then if you're not given the grams, you're just given volume, temperature, all the other stuff, then you have to use the equation, this route right here, and then stoichiometry. So there's a pattern, and with more practice, you will develop that pattern, and that's the whole point.